In this video, I'm going to do some more examples on section 2.3, that is modeling with first order equation. Okay, so the example 1 and 2 was done in the last video. Now this is example 3, which is question number 5 from the textbook. Okay guys, so let me read the question. It says a tank contains 100 gallon of water and 50 ounce of salt. So there is 100 gallons of water there, and where there is 50 ounce of salt at the beginning. Okay, water containing a salt concentration of 1/4 plus times 1 plus 1/2 sine t ounce per gallon flows into the tank at a rate of 2 gallon per minute. Okay, so it is flowing into the tank with 2 gallons per minute. Okay, but per gallon it contains 1/4 plus 1/4 times 1 plus 1/2 sine t ounce per gallon concentration, and the mixture in the tank flows out at the same rate. So it is going out with the same rate of 2 gallon per minute, right? The question is, find the amount of salt in the tank at any time. So you want to solve for amount of salt. We assume that as QT. Okay, and plot the solution. Plot the solution and see the behavior of the graph. Also see what happens to the solution in the long run. So there are 3 questions here. Okay, so first of all, we need to find out the solution of, first of all, we need to set up differential equation, and then we will find out the solution. I mean, we will answer these questions. Okay, so let us do this problem. Solution. Let QT be the amount of salt. Then, so dq over dt equals to Ri, inflow rate, times Ci, concentration, right? And then minus outflow rate times the concentration, right? So R0 is outflow rate and concentration is Qt over the volume, right? Vt. This is the formula, right? So what is Vt? The Vt is the volume. So see, this volume of the solution does not change because the inflow rate equals to outflow rate. So it is coming in, flowing in with 2 gallons per minute and flowing out with 2 gallons per minute. So the volume does not change. So what is the initial volume there? It is 100, right? So it is 100. So what we do is we keep Vt equals to 100, right? So we keep Vt equals to 100, which is constant. Now what is the value of Ri? Ri is, so it is an inflow rate, right? That is 2. So Ri is 2. Ci will be that value, right? Ci will be that value. And then R0 is 2, right? And then Qt over 100. That's what you will get. Okay, so you will get dq over dt equals to Ri is 2 times 1/4 1 plus 1/2 sine t minus 2 times Qt over 100, right? So if you simplify this, what do you get? Let me simplify that. So 2 divide that, so 2, this will be 50, right? So this will be 2. So what do you get if you simplify? You get dq over dt equals to, so 1/2 left, right? So 1/2 times 1 is 1/2 plus 1/4 sine t minus 1 over 50 Qt, right? That's what you get. So we want to write this in the linear form. So what we want to do is you want to move this. You want to add 1 over 50 Qt on both sides. So you get dq over dt plus 1 over 50 q, okay, equals to 1/2 plus 1/4 sine t, which is the standard linear form, right? It is like derivative term and then something, a function of t times q equals to another function of, so it is like dq over dt plus pt times that q variable plus qt, right? So how do I solve this? You need to use the integrating factor, right? So what is the integrating factor here? Integrating factor is e to the 1 over 50 dt. That will be e to the 1 over 50 t. You see that? So you multiply both sides by that. What do you get? You get e to the 1 over 50 t times dq over dt, right? And then plus e to the 1 over 50 times 1 over 50 times q, right? So I'm multiplying everything by 1 over 50. Oh, by the way, there is t, right? T times 1/2 plus 1 over 4 sine t. That's what you get. Okay, so on the left side it is always d over dt, the q function times the integrating factor 1 over e to the 1 over 50 t. That's the left side, right? Equals to, on the right side it is just the same thing. I mean, you can write e to the 1 over 50 t times 1/2. Let me write down 1/2 there, and then plus 1/4 e to the 1 over 50 t times sine t. That's what you get. Now we integrate on both sides. So let us integrate on both sides. What do you get on the left side? Left side becomes q times e to the 1 over 50 t, right? On the right side, the integral of this will become 1/2 times e to the 1 over 50 t divided by 1 over 50, right? Why is that? Because the formula of e to the ax is equals to e to the ax over a plus c, right? And then dx there. That's what I'm using there. Plus, this is the product rule, right? So how do I do the product rule? So e to the, let me do that, e to the integral of 1 over 50 t times sine t dt. Okay, so this is in the form of e to the ax times sine bx, right? What is the formula for that? Let me write down the formula for that. The formula is in, I mean, you will have to use the integration by parts twice, right? So let me write down the direct formula. So e to the ax times sine bx dx. The formula is, so the formula for integral of e to the ax sine bx dx is, the formula is e to the ax over a square plus b square, okay? And then in the bracket, you write a sine bx minus b cosine bx. And then plus c. So this is the formula for integration by parts of e to the ax times sine bx. That's what I'm going to use it here, okay? So what do I get is, let me write the right side only for now, equals to, so how much is that? This is 1/2 times 50 over 1, right? Because there is a fraction in the denominator. So 50, 1/2 times 50 over 1 will be 25 e to the 1 over 50, right? And then t, you see that? And then plus e to the ax. What is e to the ax? E to the 150 times t over a square plus b square. It is like, what is a? A is this one. That is a. 1 is b. There. Okay, that is 1 is b. So a square plus b square will be 1 over 50 square plus 1 square. So 1 over 50 square, 1 over 50 square plus b square is 1, right? And then, so that is, let me, I don't need bracket there. This is e to the ax over a square plus b square, and then bracket a sine bx. That will be 1 over 50 sine bx will be just t. Instead of x there is t, right? and then minus b is 1 cosine bx is also t. That's what you get, right? So ultimately what you get here, let me write down in better format there, okay? So what you get is 25 times e to the 1 over 50t plus e to the 1 over 50t divided by, what is 1 over 50 square? That will be 1 over 2500, right? 1 over 2500 and then plus 1, okay? So you get 1 over 2500 plus 1, right? And then inside the bracket there is 1 over 50 sine t minus cosine t. That's what you get, okay? Now what I'm going to do here is I am dividing both sides by, because on the left side there is q times e to the 150t, right? I'm dividing both sides by that quantity, e to the 150t, because I want to solve for q, right? And divide this by e to the 1 over 50t. So that's the product form, so you don't need to divide those, right? So you get that will cancel out, that will cancel out, this and this will cancel out. What you get is q equals to 25 plus, how much is that? 1 over, there is 1 in the denominator, you can just combine those, right? So that will be 2500 plus 1 will be 2500, 1 divided by 2500 and then times 1 over 50 sine t minus cosine of t, okay? So basically what you get there is, let me move that to the top. So you will get qt equals to 25 plus 2500 over 2501, okay? And then in the bracket 1 over 50 sine t minus cosine of t. So do you know what is the initial condition here? Initial condition of q is 50 ounce, right? So you can write where, let me write in different color, q at 0 equals to 50. So plus c, oh, I should not forget that plus c thing here. Whenever I integrate, I need plus c here. Let me write plus c after you write integral. So plus c, plus c, plus c. So let me use that q0 equals to 50 ounce. What do you get? So plug in 0 for all the t, right? So this will be 0. This will be cosine 0 will be 1, right? And then this is 25. So you will get 50 equals to 25. And then minus, because these times that will be negative, 2500 over 2501 plus c, okay? So what do you get then? Then you will get, let's see that. So you will get 50 minus 25 will be 25, right? So 25 plus that. So this implies c equals to 25 plus 2500 over 2501, okay? So there is a 1 in the denominator, you see that? 1 in the denominator. So if you combine those, basically you will get, this is what you get, okay? 65025 divided by 2501, okay? By the way, I forgot to divide this c by 1 over 50 e to the 1 over 50t. So it will be c times e to the negative 150t, right? So this implies, so there will be plus c e to the negative 150t, right? That's what you get. So now when you plug in q0 equals to 50, then you get c equals to that value, okay? So this value goes here, right, in place of c. That's what it goes. Okay, let me write down the final version of that, the solution. So qt equals to, you get 25 plus 2500 over 2501, okay, times 1 over 50 sine t minus cosine of t, and then plus 65025 over 2501 e to the negative 1 over 50 t times there, right? This is the final solution. This is the final solution for that. Okay, guys. Now, so the next question was, we want to plot the solution. Okay. So let me use that software that we are using for the direction field to do that. So I will plot the right hand side of the differential equation to see the direction field, and then we can check the solution, and we will be able to find out the long-term behavior of the solution. Okay, guys, let us see that. So what I did is I entered the right hand side of the equation for dq over dt. So here y is basically the q in our problem, right? So this is what 1/2 plus 1/4 times sine t minus y over 50 is basically q over 50 in our equation. Okay, so at the beginning, when I try for between 0 and 50 for x and y, because what was our y value? What is our initial condition for y? It was 50, right? You see that? This is what it looks like. It looks like some kind of oscillation, right? But it doesn't, we cannot say where does it go. Is it going to the 0 or is it going to some certain number? So what I'm going to do is I'm going to expand the domain for t, right? So if I do that, you see this? So it is going to almost like certain this line almost. You can check by plugging in the different other solution curves for different initial condition. Okay, if the initial condition was 40, then it would go like this. For 30, it would go like this. If the initial condition was, see, for all those initial condition, it looks like it is going to certain line there, right? It is, all these solutions are going to this horizontal line. So it is like when t is bigger, when t goes to infinity, I would say, then the solution is going to 25. That's what you can say. And it is oscillating, right? So how do you answer number B? Number B, the solution, because of the sine t and cosine t, right? Solution curve oscillate. This is what we see, right? The solution curve basically oscillates. All right. And where does it go, by the way? So it oscillates, but it goes to almost 25, right? The solution curve oscillates. And number C, in the long, it goes to 25. Why it is going to 25? You can see this. So when t tends to infinity, this goes to 0, right? This goes to 0. And then t, sine t and cosine t, it will be a finite number. But this is a small number, right? It is less than 1. So it is less than 1. This is also a small number. So this will be a small number. So almost, the solution will be almost 25. You can see from here, right? Because see, 25 over 2500, 1 is less than 1. And times 1 over 50 is even less than 1, right? And then minus cosine. So cosine and sine values are between -1 and positive. So they do not contribute that much. This goes to infinity. But what is left is just 25. That's why in the long run, it goes to the solution, or the concentration of the salt will be 25 ounce. That's what you see, right? Let us do another example, which is related to a cholesterol level of a person's body. So this example is question number 8 from your textbook, okay? Cholesterol is produced by the body for the construction of cell walls and is also absorbed from certain foods. The blood cholesterol level is measured in units of milligrams per deciliter or mg per dl. Okay, this is question number 8. The net cholesterol production or destruction by the body is modeled by a rate R per day times the difference between the body's normal cholesterol level, which is a constant, and actual cholesterol level at any time t. The rate of absorption from the food is estimated as a constant K in milligrams per deciliter per day. Question number A is, a person's cholesterol level at the start of testing period is 150 milligram per dl. Find an expression for the cholesterol level at any subsequent time t. If the rate R is 0.10 per day and the natural level is 100 milligram per dl, find the cholesterol level of the person after 10 days of the starting of the testing period in terms of K. That's what the question number A from question number 8, page number 65. Okay, so let us denote that. So let us denote that C is the cholesterol level. Okay, so let C is cholesterol level. At let's do C and then T. Okay, that will be better, I think. CT is cholesterol level at time T. Okay, also the question is stating, let's say CN is natural cholesterol level, which is the constant. Question gave this, right? And then also and K is given by rate of increase of the cholesterol. So cholesterol rate by food, so it is increase rate. Okay, so the question is giving that the rate of the change of the cholesterol of a person's body is equals to a rate R times the natural cholesterol minus that cholesterol level. That's what question is giving. Okay, so by question what is given is dC over dt equals to, it is given by R times natural cholesterol minus the cholesterol level at any time plus cholesterol from the food. That's what it is giving. Okay, also in question number A, it is given that C at 0 equals to 150. Okay, this is given to us. All right, so we want to solve this differential equation. So this is the cholesterol level at any time C and at any time T. Okay, now to solve this, so this is constant, this C sub n is constant, K is also constant, but so what we want to do is, I want to distribute this R dC over dt equals to RCN minus RC plus K, right? And I want to move this RC to the left side to make it linear. dC over dt plus RC equals to RCN plus K. That's what you get. Okay, so let us find out the integrating factor is e to the integral of R dt. That will be e to the RT. So I want to multiply the whole equation by e to the RT. If I do that on the left hand side after multiplication, you will get, so what I am doing here is basically this, right? Multiply this by e to the RT and then multiply this right hand side by e to the RT as well. That's what I am doing, right? So on the left side you will get d over dt C times e to the RT, okay, equals to, and in the right hand side you have R times Cn plus K e to the RT. That's what you get, right? So here C sub n, okay, this is a natural cholesterol. That's what I mean here, natural cholesterol. Okay, you can write n and then sub C, natural cholesterol, like that. Okay, now let us integrate. If you integrate, what do you get? You get C times e to the RT equals to, on the right hand side you get R times C sub n plus K e to the RT divided by R, right? Because the integral of e to the RT is e to the RT over R. Now divide by e to the RT and plus C. Divide by e to the RT on both sides. What do you get? You get C of T is equals to RCN plus K divided by R. You see that? and then plus c e to the negative rt. And let us use c at 0 equals to 150. What do you get? You get 150 equals to, oh, by the way, this is r times cn, right? So if you distribute if you split the denominator, you get cn plus k over r, right, plus c, right, because that will become 1, right? E to the 0 will become 1 because we are taking t equals to 0 here. Therefore c equals to 150 minus cn minus k over r. Hence, so what is the answer to the question number A? Is CT equals to, you get cn plus k over r plus 150 minus cn minus k over r times e to the negative rt. So this is the solution. This is the solution curve. Okay. Now, what do we do with the so the question on number A is also, it is given that if r is 0.10, let me write down that next. If r equals to 0.10, that is given per day, and the natural level is 100, cn is 100, this is also given. Find the cholesterol level of the person after 10 days. So you need to find out C10 equals to what? That's what it is asking. Okay. So what we need to do here is, you need to plug in these values. Cn is 100, K is K, you leave K, R is 0.1. Okay. So let's do that. So you get C at 10 is equals to 100 plus K over R is 0.1. Okay, plus 150 minus 100 minus k over 0.1, and then e to the negative 0.1 times 10. Okay, now you use, so how much would that be? That would be 100 plus, what is 1 over 0.1 is 10, right? So 10k, and then plus, what is 150 minus 100 is 50 minus 10k, right? To the e to the, how much is that? E to the negative 1, right? So 1 over e. So this is the cholesterol level after 10 days in terms of k. Okay, guys, this is what you get in terms of k. All right. So that is basically question number A. For question number B, let me read question number B, okay? So let me erase this first. All right. So question number B is, this is question number A, okay? So question number B is, it says if k equals to 25, if k equals to 25, what is the cholesterol level of this person after a long time? So what we want to do here in this case is, we want to use this equation, okay? Not the part A. We want to use that equation, okay? Then what happens? CT is equals to Cn plus k over r. That will be 25 over r, right? Let me do that. So 25 over r plus, okay, 150 minus Cn, okay, and then minus 25 over r e to the negative rt. So when t tends to infinity, what happens? This goes to 0, right? This whole thing will go to 0, right? This whole thing will go to 0. That means you get Cn plus 25 over r, okay? Now, if you use the value from A, here, part A here, what were the value of Cn, and using Cn equals to 100 natural cholesterol level and R equals to 0.10, what do you get? C at T tends to, you get 100 plus 25 over 0.1. That will be, if you do that, you will get 350. So as you can write T tends to infinity. That is part B. Let us do part C. Suppose this person starts a low cholesterol diet. What must be the value of K be? What must the value of K be so that the long-term cholesterol level is 180? Okay. So this is the formula for long-term cholesterol, right? Meaning when T tends to infinity, this is the formula for T. Okay. So what must be the value of K? So let me write down K here. So let me say that. Let me use this equation. Okay. When in the long term, then CT will become Cn plus K over R, right? Because you see that this term will go to 0. That is the reason. Now what the question says that, so if you want to keep your cholesterol level at 180, if you want to keep this 180, and Cn, let's use that same Cn value from A, so it is 100, right? And then plus K, so it is asked K over R is 0.1, okay? Now let us solve this. What do you get? So 100 minus, let's subtract 100 on both sides. You will get 80 equals to K over 0.1, right? So what do you get? So this implies if you multiply both sides by 0.1, you will get K equals to 8. So you need to get the cholesterol from food by 8 mg per dl. That's what you need to get if you want to keep your cholesterol level below 180. That is the maximum number of cholesterol you can obtain from the diet. Okay, guys. So that was question number C, and that is the end of this question number 8 from the book. Okay. Hi. So this is the next example is the use of or the application of first order equation in the compound interest. Okay. So you may remember that from the college algebra that if you invest an amount P0, okay, in an interest bearing account in which the principal is compounded continuously at a rate R per year, then this is what you get the amount after time T, right? After time T, this is the principal, because what is happening here is that interest, the compound interest, meaning that the interest will be added to the principal, and the new principal will be the interest plus the previous interest plus the previous principal, right? But since it is compounded continuously, so every time, like every second or every portion of the second, like fraction of the second, it is interest is calculated and added to the principal. So this will be the principal at time T. Okay, is given by P sub 0 initial principal times e to the R times T, where R is the interest rate per year, right? So in terms of the differential equation format, so this is dP over dt equals to Rp, because if you solve this, you will get exactly this equation. Okay. Or in other words, you can say that if you find out the derivative of this, so the derivative of this is equals to R times that function. This is what you get. And P at 0 is equals to P0. Now, sometime, so in addition to the compounding interest, you may want to add certain amount every year in that account. Okay, that addition is K, or you may want to subtract or deduct certain amount, or you may want to withdraw certain amount from that account. In that case, the K will be negative. If K is positive, meaning you are adding certain amount every year. Okay, in that case, The differential equation for that compound interest problem will be dp over dt equals to r times p plus k. Again, if k is positive, meaning you are adding amount every year, okay, k dollar every year. If k is negative, then you are deducting k every year, okay. All right, so I want to do question number 11 from the book that uses one of these two formula. So so another will be the homework problem, okay. So you will see a homework problem similar to the one that I do, maybe even easier than this. Okay, let us do question number 11. Let me read question number 11 first. What does it say? A young person with no initial capital. So that means P0 is 0. That's what it is saying, right? A young person with no initial capital invests K dollars per year at an annual rate of return R. Assume that investments are made continuously and that the return is compounded continuously. Number A, determine the sum as T. So it says as T is the sum. Okay, let us do that. So it is given, okay, as T is the sum of the interest and the principal, right, accumulated at any time t. So you want to solve for as t. So instead of p, the question is asking, assume that is s, okay. So what is happening here is the initial investment P0 is basically, it will be 0, okay. This will be 0, but the K will be positive there. Here, initial investment is P0, but there is no yearly addition or deduction. But here, there is yearly deduction K dollars, okay. But there is initial investment is 0. So how does the equation look like then? So the equation will look like ds over dt, because the question is saying st is the sum or the accumulated sum, you can say, equals to rs plus k. That's what you get, okay. And then s0 is equals to 0. Now we need to solve this. This is a linear format, right? So you can write ds over dt minus rs equals to k, right? What is the integrating factor? Is e to the negative integral of negative r dt, right? That will be e to the negative rt. So if you multiply both sides by the integrating factor, you will get negative e to the negative rt times ds over dt minus rt equals to e to the negative rt times k, right? So what you get is d over dt s times e to the negative rt, okay, is equals to, now this will be k times e to the negative rt, okay. Now if you integrate, what you get is, you get s times e to the negative rt is equals to k times e to the negative rt divided by negative r, right? That's what you get, okay. And and then plus c, right? So let us divide by e to the negative rt. What do you get? S equals to, you get k, negative k over r, right? And then plus c times e to the positive rt. That's what you get. You see that? C times e to the positive rt. Now let us set that s0 using s at 0 equals to 0. We get 0 equals, because this is st, right? 0 equals to negative k over r plus, you set t equals to 0, you will get c. This implies c equals to k over r. So what is the final answer then? Your final answer is st is equals to negative k over r plus c is k over r e to the rt, right? Positive rt. So if you take k over r out, you get st is equals to, let us take k over r, you can write e to the rt. Let us write the positive term first and then minus 1. This is what you get. This is the solution in terms of r. So this is the solution of st at any time t, okay. This is part A. This is the answer for part A. So the next thing we want to do is, let me erase this first. So question number B for this is asking, So B is if R equals to 5.5%, okay, determine K, find K such that 1 million will be available for retirement in 42 years, such that 1 million will be accumulated at the end of 42 years. Okay, so what was our solution again? The solution I erased just now was given by as t equals to k over r e to the rt minus 1, right? This was our solution. Now the question is giving that s of 42 equals to 1 million, right? 1 million. This is what is given, right? Now you use that and then solve for, you need to solve for k, right? Because r is given. So what is r? R is given at 0.055. That's r, right? So you just use that thing. So use it into that equation. So you get 1 million equals to k over 0.055, right, times e to the r is 0.055 times 42. T is 42 minus 1. So if you solve this, how do I solve this? Just use calculator for this, okay? So you need to multiply both sides by 0.055, okay? So multiply by 0.055. And then just find out this, e to the 42 times 0.055 minus 1 and divide by that. So you will get, let me use calculator for this. So that is 55,000. So if you multiply both sides by 0.055, you will get 55,000 equals to k times 9.0744. So you get 9.0744. So divide both sides by 9.0744. So you get 55,000 divided by 9.0744. You get 6061. So K equals to 6061.0067. That's what I got as the answer. Okay, guys. So that was part B. Part C is if K equals to 4,000 per year, determine the return rate R that must be obtained to have 1 million available in 42 years. So C is if K is, if you collect $4,000 per year, okay, find R so that you get your total amount will be 1 million in 42 years. You need to find out K again, right? So again, so T is 42, right? And then you do exactly the same thing as we did here. So you get 1 million equals to K is 4,000, right? Divide by R is R, and e to the R times 42 minus 1. You see that? So you divide both sides. To do this, what you need to do is, so it is not very easy though, because there is e to the r. So I think we need to try different values of r. Okay, so let me divide by 4,000 first. Divide by 4,000 in both sides. So 30 and 30 cancel out. So it will be, how much is that? 250. So you get, so 4,000 divided by 4,000. That will cancel out. So you get 250 times r. I multiply both sides by r. You get e to the 42 2r minus 1. Okay, so this is very hard to solve. So one thing you can do is you can use calculator to solve this. TI 8384. What you do is you just move this to the right side, okay, and then plot that e to the 42 x minus 250x minus 1, and then see where it cross x-axis. That's one way. Okay, so the other way would be, you can say, try different values of r. Try r equals to 1 and then see if left side and right side are equal. Try r equals to 2 and then see if left side and right side equal, and 3 and then 4 and so on. Okay, keep trying that. I think you will get r equals to almost 7%. Almost 7%. Okay, that is 0.07. You will get almost 7% r if you try different values of r. Okay guys, so this is how we use first order linear differential equation in the compound interest problem.